Hi everyone, this is our final project presentation for CS5800 algorithms course, and the topic for our presentation is file compressor and decompressor tool. I'm Rajeshwari and my teammates are Sriker, Sahith and Ravi. So in this presentation, we will walk you through our main motivation for working on this project, the solution that we propose, project goals, and we are using Huffman encoding algorithm. So we will be talking about Huffman encoding algorithm in this presentation. And then we will talk about the approach to our algorithm. Then we will walk you through our code design and solution. And then we'll talk about how our code works and the kind of input that we will be giving to our algorithm and the expected output from it. And finally, we will talk about the conclusion and future scope for our project. So our main motivation to work on this project. All of our teammates have at some point or the other faced issues with using online third-party file compression tools. So whenever we try to share files online using a third-party compression tool, the privacy of our data is compromised. We had an incident where one of our teammates used a third-party compression tool to compress a file, and then he shared a file, and then he shared that file with one of us. And when we decompressed it into one of our laptops, we got a malware installed on it, and we had to reboot the whole system. Not only this, we feel that the file contents may be altered or misused when we use the third-party online compression tools, and there is no guarantee that it is secure. Plus, we can save a lot of memory space in our systems if we can somehow securely compress files without using any third-party compression tools to store them. So for all these problems, the solution that we propose is we propose to build our own compressor decompressor tool, which can be used to compress text files and decompress them. We plan to use this tool and share it amongst ourselves so that we can share data and other files by compressing and decompressing it. We will be using Huffman encoding and decoding technique to build the compressor decompressor tool. So the project goals here. So we will be using the techniques and skills that we have acquired through CS5800 course and whatever we have learned from the course modules, approaches like greedy algorithmic approach, data structures like arrays, trees, etc. will be used to solve our file compression problem. We'll be leveraging the Huffman encoding and decoding algorithm, which is a greedy algorithm, to solve our problem. And finally, our project goal is to build a compression decompression tool, which we can utilize amongst ourselves whenever we want to share files with each other without the risk of any privacy breach and with some security. Now my teammate Sahith will talk about Huffman encoding and decoding algorithm.
Huffman algorithm is a greedy algorithm which does lossless comparison or compression of data, and it is most widely used algorithm for data compression. It is generally a tree-based encoding in which one starts at the root of the tree and searches the path till it ends up at the leaf. So the value at the leaf is the character represented by the encoded bits. Huffman coding is generally used to compress the data in which there are frequently occurring characters. Most frequent character gets the smallest code and the least frequent character gets the largest code. So if you assign less number of bits or shorter date code words for most frequently used symbols, you'll be saving a lot of storage space. A general greedy approach to construct Huffman tree for n characters is place n characters in n subtrees. Next, start by combining the two least weight nodes into a tree, which is assigned the sum of two leaf node weights as the weight for the root node. So do this until you get a single tree. And we can traverse the tree to get the coded data for each character. So we generally use this algorithm as this encoding schema results in saving a lot of storage space, as said earlier, since the binary codes generally generated are variable in length. And it generates shorter binary codes for encoding symbols that appear more frequently in the input string. Now Raviteja will continue with the code design and general approach for the code.
To begin with, we provide options to the user to either compress a file or to decompress a file. To compress a file, a user has to enter the file name to be compressed. We accept a .txt file as input and pass it to read each character of the file into a string builder. And then we convert each of these words into strings and later convert these strings into a character array. So we have all the characters present in the file as a character array. Now we loop through the character array to calculate weights of each character occurred in the file. Now we create an instance of the Huffman utility class and call the start Huffman method by passing the character array and the weights array. We are also calculating the compression ratio and displaying it when we compress a file. To compress a file, in the start Huffman method, we take the character array and the frequency array and create a leaf node for each unique character. And we also create a frequency list which stores the weight of each character and map it to the index in frequency class. When we then start with building our final Huffman tree, first we take two nodes with minimum character from the list in the initialized class, and we start the two node index in an array. Next, we create a new node with a frequency equal to the sum of two selected nodes from the initialized class and make the first minimum weight node as the left child and second minimum weight node as the right child. We then update the tree value and decrease the frequency tree list size. As we combine two nodes, we then repeat this process until tree size is empty. We assign value as 0 for all the nodes in the final Huffman tree and value 1 for all nodes in the right subtree. In Huffman tree class, we store the new code for all the unique characters in the character array. We can also calculate a get for a specific character using the get code method. Finally, we extract the code by traversing the whole tree and map the Huffman code with the ASCII value of each character, and then generate a new .compressed file with the Huffman code in the compressed file method. To decompress a file, we have to pass a compressed file as an input for the to the decompression method. It recognizes the file extension for compressed files. It recognizes the codes that each character is represented by using the start Huffman and codes function, and accordingly reassigns characters back to the file and decompress it. We extract the code from the input file, which needs to be decompressed, and compare each bit with the Huffman tree value. And when we reach a leaf node, a character has been generated with the help of Huffman code and ASCII value mapping and stored it in a variable. After generating all the characters, we will push the characters to a text file. And coming to the input and execution, input is a text file name which needs to be compressed or decompressed, and choose whether the file has to be compressed or decompressed. While execution, weight of each character is displayed and its Huffman code. And also we are also calculating the compression ratio, like how many characters are there before and how many how many bytes are there before and how many bytes are there after the compression. And as an output, we are generating the .compressed file and storing it in the preferred location. And now my teammate Sriker is going to present about the conclusion and the time complexity and all.
So coming to the results part, the algorithm performs as expected. It compresses the test files using Huffman encoding technique. After compressing, it shows the character code associated to each character and also the encoded message length. The algorithm also performs correctly in terms of decompressing and decompressing the compressed test file. After decompressing, it shows the statistics of file size and codes. Analysis and time complexity. The time complexity for encoding each unique character is based on its frequency and its O of n log n. Extracting minimum frequency characters from the tree takes place around 2n times, and its complexity is log n. So the overall time complexity of the algorithm is big O of n log n. Coming to the conclusion part, as proposed, we have built a file compression and decompression tool using Huffman encoding technique and decoding algorithm, and we are satisfied with the results as the compression ratio is 50%. We feel comfortable using these tools among ourselves to compress and decompress files, which we want to share among ourselves. Coming to the future scope, we will enhance our project work and calculate the entropy and display the in-depth statistics, like how much file space is saved by using our algorithm. We also plan to develop a front-end UI to this tool and deploy this tool in the web. We are also planning to work on this algorithm further to increase the compression ratio and make sure that it supports the compression and decompression of image and video files as well. Thank you.